study of the earth sciences. And take a look at my Google Earth here. Just like my YouTube, they can tell you a lot of things about where I'm coming from. What I love about a program like this is it's three-dimensional. You really cannot study the Earth without being able to see it in its more fuller form. When you're looking at maps, whether it's your favorite projection or not, these projections are not accurate. And the only way you can do something is by animating it. You can do this with a globe, a physical globe, of course, a desk globe or whatever you want to call it, because that's physical and it's three-dimensional. But Google Earth gives you the simulation of three-dimensional. And it's not that just that you can get the curvature to the edges of what you can see, and that gets distorted because it's compressed the closer you go to the edge. But it's the fact that you can change the perspective. That's really what I'm getting at here. So for example, you see what I'm doing is that I'm giving you a rotation of the Earth from so-called upside down, down under. I'm giving you the perspective where it's actually going somewhat in the direction that it goes, east to west. But now let's try this. We'll try it on its side and we'll go the other way. So, the Earth doesn't move this way, but if you're moving around the Earth, hypothetically, you could see it this way. And it's kind of nice because you can change it and it helps your thought process when you're able to move it all around. Being able to see things to where you see, I've got, like here's the angle that if you look at the Earth from this point of view above it, you can see more land than you can see about right here from any other perspective. From right here, there's more land from this angle than any other angle. You choose any other angle and you're going to get less land. So I'm sure there's a technical term for this, but if you notice that it puts Moscow at the center of the world. And Moscow, of course, is here. For some reason, we get a little bit slow because I'm uploading a video right now. There is Moscow right in the center of the bullseye. Okay, so let's come back out. Let's come back. And this truly shows you the strategic importance of Moscow and its power in the world. It's literally at the center of more landmass than anywhere else. Now, if you shift this and say you go down here, you're taking in more of the Indian Ocean. Let's take in more of the Indian Ocean. So here you're centered on the Indian Ocean. You see mostly water, and you see the edge of Africa, India, Southeast Asia, Australia, and Antarctica on the edges. So you're not seeing a lot of land. You're not in the center of land here. Let's give you another example. We'll go to the South Pacific, and here you have barely any land. In fact, this is kind of the center of the world of water instead of the center of the world of land. You mostly have water out here. When you get out there, man, you're stuck with water. And it's hard to go across here unless you're prepared for a long travel and you're prepared with a lot of fuel for your plane or your ship. Okay? Now let's go up, we go up into the North Pacific here. Here's Hawaii, right here. And you see a little bit more land because you've got this where they say there was the land bridge, which there probably was, but I don't know how long ago that land bridge would have been there. And the nice thing that if you want to kind of mess around with stuff, of course there was a land bridge at some point, and you can put a line across there and you can save it, and it'll show you the altitude, and you get an idea of the topography. You know, elevation's a big part of topography. So once you plot that trajectory, you can show the elevation of it. It's going to zoom in a little bit. So what I figure is like the land bridge was probably here at the shortest distance. And you'll see the land drops off down. I don't know why it's showing 3 feet there. That's like a shelf. See how it shows 3 feet? This is supposed to be 3 feet all the way across. That might be a mistake. But anyhow, you go down, you're down into the Bering Strait here, part of the Bering Sea, and your depth along here, are you seeing it? It's like about 100 feet or just over 100 feet. That is crazy. So you're coming up to the Alaska side over here, and I mean, you're at 10 feet, 30 feet. You go way out. You go a few miles out, and you're only at 80 feet. This is very shallow. Okay, this is extremely shallow area. This is extremely shallow. There's no trench here at all. I mean, this is just shallow. If you're a good swimmer, you could go across here. I mean, I'm sure there's a lot of currents that are going to shoot through here at certain times of the year. But, you know, you've got this information that they put on Google Earth. Can't seem to get anything to come up. But, this is probably where the land bridge was. And the reason why I'm showing you is because Fairway Rock. So that's the rock that's in the middle of the strait there. Beautiful. Beautiful. I'm showing you because I always doubted that this is the way that people mixed in and species mixed in. But obviously some movement and migration happened across here. I just don't believe that it's the only source of people. It can't be the only source of people, because I think that people pre-existed on the North American continent independently. I don't subscribe to the idea that everybody came from Africa. I don't subscribe to that. That means that if all the first humans came from here, that they had to travel out this way and then this way and then over to here and then all the way over to here to get to South America. If they did come from a single source, a singular source, they also could have used boats to cross the water. Okay? Now let's get into the nitty-gritty here, because I showed you a formation in my last video, and it starts here. The reason why I was up here by the Bering Strait in the first place. Over here on the end, this is the end of the Aleutians, and I guess they call this North Point. This is still part of Alaska, I think. I think all the islands there are United States, and you've got a lot of wildlife, because it's almost inhospitable to people, but you've got animals out there. I'm not sure where the boundary is, but correct me if I'm wrong. I think this is, wait, I guess this is I guess these islands are not Alaska. But this is not political. I don't care about politics right now. Here, this is obviously part of the mainland of Russia, the Siberian side. And what I'm getting at is, you see this formation that comes in here? You've got like a kind of a trench, a shallow trench, then coming up to here. Look at the shape. Okay, now you pull away from here. Pull away from here, and you have this spine of formations here, like an island chain, but it's actually seamount because they still are submerged. Seamount all the way down to here till you get to the Midway Islands, and then it connects to Hawaii. So Hawaii is like at the end of this chain here. Somewhat of a chain. So look at how this just unzips. It's just unzipping away from here. Now, I've never heard anyone else go over this information, but I'm going to follow this down now to here, to the other side of the world, practically the exact other side, and you see another form of unzipping that's going on. So this is very interesting that on both sides of the planet this is going on, and it's just something that should be studied very carefully to find out.